In 1949, a man named Joseph Woodland sat in a chair on Miami Beach, doodling with his fingers in the sand. Woodland had quite a mind. He had worked on the Manhattan Project during World War II. Then, after the war, he continued his studies at Drexel in Philadelphia. And it was at Drexel where he caught wind of a local grocer who wanted a faster way to inventory and check out products. Woodland thought he had an answer: a machine-readable label for each item in the store. He'd need a simple code for the label, something a machine more akin to a typewriter than a modern-day computer could read and log. Suddenly, he realized he already knew one: Morse code. So, he started drawing dots and dashes in the sand. This is the Lightbulb Moment, a Cheddar and CuriosityStream original series. The modern barcode faced constant challenges, overcoming decades of naysayers and failures before it finally took over our stores. These little sequences of black and white bars are everywhere. They've been part of the technological bedrock that has fueled the rise of everything, from massive companies like Walmart to world powers like China. That's where we're going, but it all started with those doodles in the sand in 1949. A strange turn of events had sparked that epiphany on Miami Beach. It began with a Philadelphia area grocery chain executive in the 1940s who'd simply had enough. Running his operation was a nightmare, and the problem was industry-wide.
You had people manually putting price stickers on products. You had people manually then hand keying those prices into a cash register and really spending time with every single product that a shopper was taking through the checkout.
That's Carrie Wilkie from GS1 US, the organization that coordinates and standardizes barcodes in the United States.
There was a lot of inefficiency and a lot of time spent for the consumers in the grocery store, really in the checkout lane, waiting to pay and exit the store.
So this supermarket executive visited a dean at Drexel and begged him to help engineer a solution to all his store's inefficiencies. The Drexel dean brushed the executive off, but one of the postgrads overheard the conversation and found it pretty interesting. The postgrad, Bob Silver, mentioned the conversation to one of his friends. That friend was Joseph Woodland. And together, the two thought maybe they could invent something to help the supermarket executive. Then, they began constructing a prototype, but soon realized the system wasn't quite working. The problem? This was all pretty advanced stuff. Theoretically, it made sense, but the actual available components hadn't caught up to the theory. It'd basically be like trying to build an iPhone with consumer computer parts from the 1980s. It just wasn't going to happen. Almost 2 decades would pass before it saw the light of day again. By the late 1960s, it became clear that the grocery executive pleading with the Drexel dean years earlier was not alone. 2 advances in particular changed the game. The first was the microchip. Invented in 1958, it set the groundwork for advanced, compact computing that could read, log, and interpret data from the scanner. The second was the laser. Invented in 1960, focused light and lasers would finally offer enough brightness for an electronic sensor to clearly and consistently read a printed code on a label. By 1972, RCA's team had created a working bullseye barcode system, ready for Kroger to test out in a real store. But Kroger worried customers might reject it. Lasers were mainly associated with advanced military applications. Kroger wondered if customers might fear a death ray, as it was popularly referred to, in their supermarket aisle. Hoping for the best, Kroger went ahead with rolling out their new checkout system on July 3, 1972, in one of their Cincinnati stores. It was a success. The system worked. It scanned codes, it tallied checkouts, and sales at the Cincinnati store went up, suggesting customers actually liked it. But the grocery industry had no idea the barcode would become so prolific.
The thought was that they would assign maybe a couple of thousand identifiers, somewhere between 7 and 11 digits. They would close up shop and they would be done.
They were actually just getting started.
Once industries saw the efficiencies that we were gaining in grocery, there was a lot of interest to move beyond grocery and use the barcode in other ways. The barcode was really doing what it set out to do. It was increasing efficiency in the distribution network, and it was really increasing efficiency for consumers. So we were seeing far shorter checkout lines and far shorter wait times in grocery stores.
Then there were the new big box stores. By the 1970s, companies like Kmart, Target, and Walmart had become a favorite new place to shop for Americans. As these companies grew into billion-dollar operations, they started using barcodes, allowing them to keep track of an ever greater number of goods on their vast store floors. Walmart in particular can credit much of its success to the barcode. The company had an aggressive expansion strategy. It helped fuel that expansion with an advanced logistics network. The sprawling collection of warehouses, trucks, shipping contracts, and tracking systems that moved goods from suppliers' factories to store shelves for consumers. By the time Walmart became America's largest retailer in 1990, they had built much of that logistics network around the barcode. As China began to open up its economy in the 1980s, this pressure for lower prices helped push Walmart suppliers to contract cheap, overseas labor. And soon, Walmart began cutting out the middleman altogether, setting up its own offices in China to teach manufacturers there how to integrate directly into their supply chain. As more and more major companies did the same thing, China's economy boomed, helping it grow from a centrally planned communist economy to the world's second largest economy today. The barcode was spreading around the rest of the world too. And now it's an essential, though understated, part of our lives.
It always blows my mind when we hear the stat that barcodes are scanned 6 billion times a day. I think we don't realize how often we interact with it. And it's not just interacting with barcodes that maybe we're scanning in the grocery store, it's the barcodes that are scanned in the postal service and in mail delivery and package delivery. It's barcodes that are being scanned in warehouse settings, surgical settings on medical products and pharmacies all around the world.
But even as the barcode has become so ubiquitous, it's changing. The standard barcodes we all have seen are one-dimensional barcodes. You might think that sounds crazy, but it's true.
All barcodes are not two-dimensional. The UPC that we are all familiar with really only goes on the horizontal axis, so it's one-dimensional.
In other words, the coded information is only in the width of the lines. The height is just there to make sure the scanner can catch the code as it swipes by. Those bars could be half as tall, twice as tall, or 100 feet tall, and they would still hold the same information. More recently, though, 2D barcodes have emerged.
Two-dimensional barcodes are typically square, sometimes rectangular, but they use squares and dots and other shapes to make up the information that's in the barcode, and they do that on both the horizontal and the vertical axis.
These include the QR codes you might scan with your phone and the strange-looking pixelated designs on UPS labels. 1D barcodes usually hold 12 digits and 0 letters. 2D barcodes can hold more than 7,000 digits and 4,000 letters.
We can put a URL, we can put more granular information about a product, and then we can allow the manufacturer of that product to really engage with the consumer in a much deeper and more meaningful way than they can in the product package.
This opens up huge new possibilities for the amount and kind of data that barcodes can hold.
Especially when we think about food, when we're looking for more information maybe about allergens or bioengineered products or things that are sustainable or recyclable or fair trade. There's so much information as consumers that we want to know about our products that simply won't fit on product packaging.
Beyond shopping, QR codes also let people do everything from accessing subway maps to finding their friends on Venmo. So as we look back on the evolution of the barcode, we can see the many strange twists and turns a revolutionary technology can take before it actually gets a chance to change our lives. In a sense, that invention has been the result of not just one lightbulb moment, but many. Now, we are seeing all sorts of new types of data carriers. And as we look ahead, only one thing is for sure. Woodland's sketch on Miami Beach has permanently changed the world. Thanks for watching. If you enjoyed the video, please like, subscribe, and don't forget to hit the bell for notifications. You can watch full 22-minute episodes every Wednesday at 8 p.m. Eastern on Cheddar's live network or anytime on CuriosityStream.